Welcome to Tech Girl Kannada YouTube channel. Basic Electrical Engineering, Domestic Wiring, Protective Devices and Safety Measures. Fuse is the simplest device used. Fuse is the simplest device used in an electrical circuit to protect against overloading or fire hazards due to short circuiting. It consists of a small piece of metal called a fusing element. It is connected in series with a circuit. Working principle: whenever excess current flows through the fusing element, heat Q is equals to I square RT is produced. Due to this, temperature rapidly rises. Thus, fusing elements melts and the current is interrupted. As a result, circuit gets disconnected from the supply. Desirable characteristic of fusing element: good conductivity, low melting point, low specific heat, low cost, non-deterioration due to oxidation. Rating of fusing elements. Rated current. It is the maximum current which the fusing element can carry without any undue overheating or melting. It is the maximum current which the fusing element can carry without any undue overheating or melting. Fusing current, it is a minimum value of the current at which fuse element melts and break the circuit. Fusing factor is equal to fusing current by rated current. Fusing current, it is the minimum value of current at which fuse element melts and breaks the circuit. Fusing factor, fusing current by rated current should be greater than 1. Fuse element is made up of copper, zinc, lead, tin, aluminium, silver, etc. Merits and demerits of fuse. Merits: it requires no maintenance, cheapest type of protection. Interrupts enormous short circuit currents without noise, flame, gas, or smoke. It has current limiting effect, negligible replacement cost, easy removal for replacement without any damage of coming into contact with a live part. Demerits: they are required to be replaced after each operation. They lack relays and complete discrimination. Breaking capacity is low. Accurate calibration of fuse wire is impossible. Rewirable fuses. Uses employed in domestic installation and in motor installations of voltage rating 400 volt and current rating 300 up to 300 ampere. Miniature circuit breaker, MCB. Have you ever imagined what happens to your household devices like fan, washing machine, oven, fridge, and many more? When a short circuit or overflow of current happens, these devices get burnt and lead to fire accident if proper circuit breakers are not installed in the devices. Miniature circuit breaker is one such safety device protect under such fault conditions. MCB works on the principle of electromagnetic mechanism. Here is the diagram. Load, bimetal strip, latch, line, strip bar, magnetic element, closed contacts line, open contacts line. Working principles of MCB. When an overflow of current takes place through MCB, the bimetallic strip gets heated and it deflects by bending. The deflection of the bimetallic strip releases a latch. Okay. The latch causes the MCB to turn off by stopping the flow of current in the circuit. To restrict the flow of current, MCB must be turned on manually. Merits and demerits of MCB. Easily identify the fault zone of an electric circuit when stripped. Simple to resume supply. Less maintenance, replacement cost. It works faster for short circuits and overloads. It has Reliability. Power restoration can be easily done. Cost of MCB is greater than fuse. MCB distribution board cost is higher than fuse distribution board. Slow tripping, aging and wear. Cannot protect against earth faults. Vulnerability to heat. Used as residential, commercial, and industrial. Both fuse and MCB are protective devices against overload, short circuit conditions. Domestic wiring. The solution of wiring system for domestic wiring depends on the type of installation, sort of installation, future expansion, etc. The commonly used wiring system for domestic wiring is two-wire system or three-phase four-wire system. The types of wiring to be adapted for taking electrical connections from the supplying agency depends on various factors: durability, safety, appearance, cost, accessibility, and maintenance. Requirements: the types of wiring selected be of proper requisitions specifications so that it is durable, does not give rise to any problems. Quite often, safety is a very important factor in selecting a wiring system, and the types of wiring system selected must be such that electrical wiring is done should not spoil interior beauty of the home. Also, the wiring system selected should enhance the appearance. The various switches provided must be easily accessible, and the plug points to be connected the various appliances must be provided nearer to the places where the appliances are usually kept. Types of wiring: casing and capping. When the wires or cables used in wiring needs protection, this method of wiring system is used. The wire cables run inside a wooden casing having grooves, usually V-shaped grooves, which is then covered with wooden caping. VIR and PVC cables are used for wiring. The casing and capping should be of well seasoned, reasoned, teak wood or any good quality wood, free from knots or any other defects. Sometimes teak wood is vanished to protect it from white ants. The length in which casing and capping are available varies from 2.5 to 3 meter. Good appearance advantages: good appearance when compared with the lead wiring system. Low quality wires, cables can be used as they are laid inside, easy to install and remove. Moderate cost: by opening the caping, we can easily inspect the wiring in case of any fault. There lies a risk of wire or wood and inflammable, as wood is inflammable. It requires better workmanship and hence labor cost is high. It is not damp proof, hence cannot be used in wet or damp places. Two-way control of lamps. NMP supply bulb A strap wires B and D. Switch 1 and switch 2. The lamp circuits used for house wiring are quite simple and they are generally controlled from one place end, such as a room lighting, bathroom room lighting, etc. In big halls, corridors, or bedrooms, it may be necessary to control the lamp from 2 points. In such cases, a two-way control lamp circuit is used for wiring. Position of switch 1. Position of switch 2. That is A, B, C, D is here. Position of switch 1 and position of switch 2. That is A to D. It is off. A to C, it is on. Lamp on or off. Look at position of this and this. When switch 1 is position A and switch 2 is position D, the lamp circuit is not closed. Hence the lamp is dark. Let it say that switch 1 is in the downstairs and switch 2 is in the upstairs. When switch 1 is changed to position B, the lamp circuit is closed and hence lamp glows. Walking on the upstairs, if the switch 2 is changed to position C, again the circuit continuity is broken and the lamp is switched off. Thus the lamp can be controlled from 2 points. Three-way control of lamps. Sometimes in a very big corridors or godowns or workshops, it may be necessary to control a lamp from 3 points. In such cases, the circuit connection required two-way switches, two two-way switches and an intermediate. An intermediate switch is a combination of two-way switches coupled together. It has four terminals E, F, G, H. Which one? Intermediate one. For one position, it connects the points E, F, and for other position, and G, H, which is called straight connection. For another position, it connects E, H, and G, F, which is called cross connection. Just like this, and P. Switch 1, AB, switch 2, CD, and this. When the switches 1 and 2 are on the position A and C, respectively, and the intermediate switch is in the position of straight connection. When EF and GH are connected, the lamp circuit is complete and hence the lamp glows. When the points EH and GF are connected, the lamp circuit is open. Hence the lamp is switched off. Now if the position of switch 2 is changed to from C to D, the lamp circuit is again closed. The lamp is switched on. Thus the lamp can be controlled from 3 points. There are 8 ways. Position of intermediate switch is whether it is straight connection or cross connection. Position of switch 1, position of intermediate switch, position of switch 2, lamp on or off. Yes, it is on, off, on, off. Equipment of safety measures. Equipment safety measures. Fuse. Fuse was first invented by Thomas Alva Edison in 1980 and is weakest link in an electrical circuit. A fuse is essentially a small piece of metal connected between two terminals mounted on an insulated base in series with the circuit. Function of fuse wire is to carry the normal working current safely without heating, but when the normal working current is exceeded, it should heat up rapidly to the melting point and break the circuit. Hence, fuse is the simplest potential protection device used in an electrical circuit against overloading or faults. Fusing element, filling powder, brass, and cap. The various materials that can be used as fuse wire are tin, lead, zinc, silver, aluminum, copper, and their alloys. Advantages: fuse is cheapest type of protection in an electrical circuit. Fuse needs zero maintenance. Operation of fuse is simple and no complexity involved. Miniature circuit breaker. Circuit breakers are electrically switching devices which are used to protect the electrical equipments from and circuits under overload conditions and short circuit conditions. When normal current is flowing through the circuit breaker is in closed position, and when current flows, it opens so that the fault current does not flow through the circuit. Miniature circuit breaker may also be used for tripping during ground faults. Magnetic element, trip bar, load, latch, bimetal element, contacts closer line. Thermal magnetic miniature element, circuit breaker is the most common consumer unit used in domestic dwellings and small commercial premises. Components: actuating layer, actuating mechanism, contacts, bimetallic strip, calibration screw, solenoid, arc divider. Actuating layer. This is movable handle, extends outside of the housing of the MCB. Actuating layer is used in manually strip and reset the circuit breaker. Actuating layer has two stable positions, on or off. Tripped positions. Trip mechanism. Thermal trip is a bimetal which heats up and binds when overcurrent flows, and unlatch a spring powered operating mechanism which opens the contacts and interrupts the overcurrent. Contacts. MCB consists of two contacts. One is fixed contact, another is movable contact. When overcurrent flows through the movable contact, moves away and breaks the circuit. The contacts are made by copper, copper alloys, silver alloys, depending on the magnitude of the interrupting current. Terminals. The MCB has two terminals. One is in the input terminal and the other is the output terminal. Calibration screens. The screw is used for the manufacturer to precisely adjust the trip current of the device after assembly. Arc divider. When the MCB opens due to overcurrents, an arc is generated which must be contained, cooled, and integuised. An arc is generated which must be contained, cooled, and integuised. Okay, merits and demerits. Merits: reliability, easy to install and use, cost effective, space saving. Demerits: a limited overcurrent rating, nuisance tripping, replacement and maintenance cost high, limited protection for high power applications, appliances. Personal safety measures. Electric shock. An electric shock occurs when an external source of electricity, such as faulty power line or lightning strike, comes into contact with a part of the body. Faulty power line or a lightning strike comes into contact with the part of body. A shock can cause a severe burns at the point of entry and emit, but it can also cause internal damage. A shock can cause severe burns at the point of entry and emit, but it can also cause internal damage. Earthing or grounding is to connect the body of an electrical equipment to the general mass of the earth by a wire of negligible resistance. Earthing or grounding is to connect the body of an electrical equipment to the general mass of the earth by a wire of negligible resistance. There are mainly two methods of earthing: pipe earthing, plate earthing. Pipe earthing. Method of pipe earthing, in which a galvanized iron pipe of approved length and diameter is used. The size of pipe depends on the current to be carried and the type of coil. According to IEEE standard, the diameter of the galvanized pipe should not be less than 38.1 mm. And length 2 meter. It should be placed to the depth 4.75 meters or to the depth. Okay, this is cast iron lid, funnel, earth electrical pipe, rod, coal. The pipe at the bottom should be surrounded by broken pieces of coke or charcoal. Earth electrical pipe is that. Coal or charcoal for a distance of about 15 centimeters around the pipe. Plate earthing. The method of plate earthing, in which a copper plate of size 60-63.18 mm is used for the purpose of earthing. An earthing plate made of copper or chromium or iron buried into the ground at the depth more than 3 meters from the ground level. Earthing plates, also known as ground plates or grounding plates, are typically made of metal such as copper, aluminum, or steel. It is an economical earthing in which a galvanized shell perforated pipe is buried in the ground. It's a copper plate, charcoal, and the common salt, pouring water, funnel that is conduct pipe, earth wire. Thank you for watching. Do like, share, and subscribe to my channel.